This is subnetting in the third octet. Let me start with a bit of a refresher on addition and subtraction in IP addresses. With numbers and IP addresses in the fourth octet, addition is fairly simple. Take this IP address. Adding 1 gives us 192.168.10.16. Now for this IP address, we add 1 and what happens? The last octet is full at 255, so adding 1 pushes into the next octet to give us 192.168.11.0. What about subtraction? Again, this one's pretty straightforward. We get 192.168.10.16. So what about this one? We cannot subtract 1 from 0. IP addresses cannot be negative numbers. So we need to take a value from the third octet, giving us 192.168.9.255. Just think of the reverse. If you added 1 to that, you would come up with 192.168.10.0. Here's one more example. The same principle applies in the second octet. Subtracting from 10.10.0.0, we take value from the second octet and come up with 10.9.255.255. Looking at the subnetting exercise, note the numbers of hosts required: 8,000, 2,000, 1,000, 10, and 2. I'll write these numbers in on my chart, adding 2, and remember we always start with the largest number first. Now, going to our reference chart, you can see that the large number of addresses require us to go into the third octet. See that the range of addresses is the same as when we were in the fourth octet, but placing them in the third octet gives us the large number of total addresses. For 8,000 addresses, we need to add 2 for 8,002, and the value we need to use is 32, which is the closest without going under. When I write this on my chart, I always like to write in third octet, or whichever octet is indicated, to remind me to add to or subtract from the correct octet. If you look here, this has us borrowing 3 bits from the third octet, which gives us a prefix of 19. That's 8 from the first octet, 8 from the second octet for 16, plus these 3 is 19. And a subnet mask of 255.255.224.0. Let's finish the left 2 columns. For 2,000 hosts, add 2. See that the range of 8 in the third octet would fit the bill. That's borrowing 5 bits from the third octet and gives us a prefix of 21. And a subnet mask of 255.255.248.0. For 1,000 hosts, add 2 and see that 1,024 would be right, so a range of 4 in the third octet. That borrows 6 bits in the third octet for a prefix of 22 and a subnet mask of 255.255.252.0. Now we're in more familiar territory, 10 hosts. Add 2, we get 12. We need a range of 16 in the fourth octet. The prefix is 28, and the subnet mask is 255.255.255.240. Finally, for 2 hosts, 2 plus 2 is 4. We use a range of 4 in the fourth octet. Prefix is 30, and the subnet mask is 255.255.255.252. Now we are ready to complete our chart. Our beginning network is 183.14.0.0. The range of 32 in the third octet means we add 32 here in the third octet to get the address of the next subnetwork, 183.14.32.0. Subtract 1 from that to get our broadcast address of 183.14.31.255. Now fill in the first and the last usable. Next, with a range of 8 in the third octet, we add 8 to the third octet to get 183.14.40.0. Subtracting 1 for the broadcast, we get 183.14.39.255. Now fill in your first and last usable. Now, adding 4 in the third octet gives us 183.14.44.0. Subtracting 1 from that to get our broadcast address, we have 183.14.43.255. Now fill in the rest. Now we're back in the fourth octet. We add 16. So the next subnetwork begins at 183.14.44.16. Minus 1 gives us 183.14.44.15 for the broadcast. Go ahead and fill in the rest of the line. Now, building on the last network, since the range is only 4, we can just fill in consecutive addresses. 183.14.44.16, 183.14.44.17, 183.14.44.18, and 183.14.44.19. And our subnetting exercise is complete. You'll get more practice on these as we go along. And remember, if you've got any questions, you can email me.